diagrams mainly for today. Okay, then maybe next week then we will look at 3 diagrams. Okay. So what exactly are probability diagrams and why do we need to know so many kind of diagrams for solving probability? Okay, because when it comes to probability, there are times where maybe we are not just looking at the situation itself and then after thinking, deciding what are the favorable outcomes of it. For example, like showing 1 die. Okay, we want to know also what would the probability be like if we throw 2 die. Okay, because maybe one of you here might be a casino tycoon in future, or maybe you are a casino tycoon's child. Okay, so you may need to know, okay, how probability may play against you or for you. Okay, but of course the whole education over here is to prevent you from picking up bad gambling habits. Okay, because it will always be against you, the probability. Okay, so let's see possibility diagrams first. Okay, so let us first consider rolling of 2 fair die. Okay, in case you ever wonder why must the dice be fair? Because sometimes the dice can be unfair in the sense that they purposely manufacture the die such that it is heavier on one side. Okay, if it's heavier on one side, then there's a chance that a particular number will be appearing. Then it will not be fair anymore. So if I were to roll 2 fair dice, okay, one die itself can have 1 to 6. Another die can have also 1 to 6. So if that's the case, what are the combination of numbers that we could be getting if I chose 2 at a time? Okay, so one possible outcome would be maybe having a combination like 2, 3. So if I write it in this manner, what I mean is that 2 is the number shown on the first die, and 3 is the number shown on the second die. Okay, so we're defining it this way. Of course, I can also have it the other way around. I can have 3, 2, where 3 is the first die and 2 is the second die. But if I really want to go out to list down all the different combinations, there will be a lot for us to list down. Okay, in fact, there will be 36 of them. Okay, how do I know that there are 36? So I can actually present this information, alright, in a different manner. Okay, so if I want to really go about listing, our sample space, in fact, will be starting from the combination of 1, 1 to maybe 1, 2, 1, 3, okay, and all the way to maybe 6, 6. Okay, it's a very tedious process. So looking at a possibility diagram, okay, I will have to draw our normal x and y axis, but we will label it as first die and second die. It doesn't matter where you label it. You can label first die over here, second die over here. That's perfectly fine as well. But since we are actually going in the definition of like a coordinate system where x, y, so we will have first die here, second die here. Okay? So the different possibilities that I can get out of the first die is numbers from 1 all the way to 6. So I will label 1 to 6. And then I also label 1 to 6 on the y-axis. Okay, if it is a possible outcome, okay, out of the situation or the scenario that we're seeing, we put a dot on it. Okay, meaning to say, if I can get a 1-1 combination, I will put a dot to represent. When you put a dot, please make sure that it is clear. Please don't just tap your pen on your paper like that. It is very difficult to see. Okay, especially if you are using a 0.38 pen. I don't have the eye power to actually spot that. So please don't draw a circle also. It's meant to be a shaded dot. Okay, so our understanding over here is that it will be 36 dots in total. I'm sorry if I'm drawing it slanted because angle of elevation and parallax error. Okay, so 36 dots to represent all the possible outcomes. Okay, so we use a possibility diagram when there are two, okay, different components to the outcomes that we are looking at. So we have, in this case, first die and second die. So if I make use of the work example found in your textbook, page 34, how we are going to find out what is the probability. For the first situation, we want to find the probability of having both dice showing the same number. So from a possibility diagram itself, we are able to visually see where that lies, okay, and that will be when 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, I don't need to go and look through the entire list and spot it. Although of course same number might be easy to spot. So noticing that there are 6 favorable outcomes for the event, and the fact that there are 36 dots, okay, because 6 times 6, 36, I will be able to get the probability of 1/6. Okay, then in part 2, if I want to talk about the number on the first die being greater than the number on the second die, okay, from a possibility diagram, I just want to emphasize possibility and not probability diagram. This is a very common error. Okay, so from the possibility diagram, I can see that the first die numbers are here, second die numbers are here. So I can do a quick run through of the entire list. Okay, this is the situations where the first die has greater number than 1. So I can always just circle it or indicate it. Okay. In the exam itself, you may not want to actually do such indication, otherwise it may ruin your diagram. Okay. So you may need to go about keeping track of how you count. Okay. So then after that, know that this are also the numbers where first die is bigger than 2, bigger than 3, bigger than 4, bigger than 5. Okay, so then you can count, there are 5, 10, 15. So 15 favorable outcomes out of 36 total possible outcomes. So simplifying it, I will get 5/12. Okay, any questions? I just want to do a quick run through of how the possibility diagram can be applied to exercise 2A question 8, which was the question that we did yesterday. Okay, in this question that we did yesterday, we had the back P and back Q. Okay, where we had red, blue, and white back P, and then in back Q we have blue and red. Okay, then after that, in terms of solving the question itself, we listed out what is in the sample space. Okay, I will not go into listing it out. Alright, so that was what we did yesterday, trying to help you recall. Okay, so how do we then use the possibility diagram? Okay, we can use the possibility diagram for this question also because there are two separate components, right, in terms of finding out the probability. So because there are two components, two bags, right, whereas over here there's two die, okay, we can draw a possibility diagram. So in the drawing of this possibility diagram, I can have bag P over here and bag Q over here. Okay, and in bag P I have red, blue, white. Q I have blue and red. Okay, so in the possibility diagram, it is not necessary that your axis has numbers only. You can have other stuff. It just really depends on the scenario that you're given. Okay, so in this case, the possibilities would be that there are six total possibilities, which is consistent with our sample size space. It's sample space size. Okay, so then in terms of finding out the probability, so in part I, if I wanted to find out what is the same color, okay, I see that I have the red, and then also blue. So I can have 2 out of 6 wanted. Okay, correct? Same color. Oh. Okay, hang on now. 6. Yeah, 6. Okay, then after that also, from this, if I wanted to find out blue and red, I will be able to find out blue red is this one. Then after that, blue red is this one. So same thing, 1/3 as well. And lastly, probability in different colors, which actually you can see that okay, so different colors will be either you can have your blue red, blue white, red blue, and red white. So there are 4 out of 6. That's why we get 2/3. But yesterday I also showed you how to do it by the converse way, okay, the complement set way. Now 3, question 1 now. We are given a fair tetrahedral die. A tetrahedral die is 4-sided and a fair 6-sided die. In the tetrahedral die, we have the numbers 1, 2, 5, and 6 instead of 1, 2, 3, 4. Okay, I'd like you to try drawing your own possibility diagram and display all the possible outcomes. Sorry, what do you mean? You can have a pyramidal kind of die. There are many kind of dies shaped. Yeah. But how is it manufactured fairly, I don't know. Yeah, I am not a die manufacturer. Okay, so display all the possible outcomes of the experiment using a possibility diagram. And then using that diagram, I want you to find probability probability of the 3 different scenarios that are given. Okay, so give you about 5 minutes to do. axis that you choose for your tetrahedral die or six-sided die. Okay, so it doesn't matter where you place it. You can have it the other way around for as compared to mine as well. Are we done? So what's the probability of both dice showing same number? 1/6. So same number, we will get 1, 1, 2, 2, 5, 5, and 6, 6. Okay, so there are 4 favorable outcomes out of a total of 24 possible outcomes. That's how we get 1/6. Okay. Sorry, I'm a bit too lazy to write the words. Okay, because I already wrote all this down. Yeah. So you know what I want to write. Okay. So part 2, the number shown on the tetrahedral die is greater than number of six-sided die. So what would that probability be like? Chloe? 1/12. How do you get? Sorry. 5/12. Okay, how do you get 5/12? 10/24. Okay, so let's do a check. So, number on tetrahedral die greater than the number of five-sided die. So let's start with this row here. So this will be the possible outcomes. Sorry, these are favorable outcomes. And then after that, we also have this. In this case, we have for tetrahedral die, we have 2, we get this one. This one we have none. So the red one will be representative of the favorable outcomes for B part I. And that would be 10 dots. So 10 out of 24, we get 5/12. Yes. And lastly, what about part 3? The number of both dice are prime numbers. Okay, so what will your answer be? Nicole? 1 out of 12. How do you get 1? Is it 1? 1 out of 4. Okay. So how did you get 1 out of 4? 6 out of 24. So let's check. Okay, so we have prime numbers. So 6 immediately is not a prime number. So these are out. 5 itself is a prime number. So 5, 5 is one of it. 5, 4 is not. Okay, so I'm reading in this direction now. Okay. Then 5, 3, yes. And then after 5, 2, yes. 5, 1, no. Okay. 1 is not a prime number. Then after that, 2, 6 is no. 2, 5, yes. 2, 3, 2, 2. So we got 6 favorable outcomes so far. For 1 itself is not a prime number already. So there's nothing for us to consider along this row. Okay, so we have 6/24, which is 1/4. That's great. Okay, next we look at question 2. Alright, slightly different scenario. Okay, it is not that we have 2 different items. In fact, we just have 2 separate, what do you call it? What's that word? Sorry. Components, yes. Okay, 2 separate components to actually consider. So we have the numbers 1 to 5 placed inside a bag. Okay, I didn't write down the full question. So we draw from the bag once. Okay, take note that we have a replacement. So this replacement word is a very important word that we need to keep a lookout for when it comes to probability. Okay, then after that, we draw a second time. That means when I first draw it, there are 5 numbers in the back. Since I'm replacing it, there will still be 5 numbers in the second time I draw it. Okay, so there are 2 different components for this scenario, and we want to find out what is the probability. And the question specifically say using a possibility diagram. So how the possibility diagram could look like in this case. Okay, is to draw our first draw and second draw and label it as axis in this manner. You can still have it the other way around, that's perfectly fine. Okay, so the numbers are 1, 2, 3, 4, 5. Okay, so 25 dots in total. Okay, part I, we want to find the probability that the number on the second card is greater than the first card. So what would that probability be? Answer? What's the probability of getting second card greater than first card? Sorry? 2 over 5. How did you come out with 2 over 5? 10 over 25. So let's check whether there are 10 favorable outcomes. So second card would be here greater than this. So this is the consideration here also. Okay, so we have we have 10 over 25, 10 favorable outcomes out of 25 possible outcomes. Okay, next, look at part 2. Sum of the 2 numbers showed more than 7. So although we have a possibility outcome, possibility diagram over here, this diagram doesn't fully tell us how do the numbers add up. So we just have to run down the list, okay, and do mental calculation along the way. Okay, so 2 numbers showed more than 7. 5 and 5 is more than 7. Let me choose a big one. 5 and 4, 5 and 3, 8. 5 and 2 is 7 itself, so no. Okay, so we run down that list. Then 3 and 5, 8, 4, 7, no, 3, 6, 2, 7. No. Is there any more? No, right? Okay, so we have these 6 outcomes out of 25, which cannot be further simplified. And part 3, we want to find the product of 2 numbers shown to be more than 10. So what will the answer be? Wei-Tan, what do you think? Out of 25. Okay, so let's do a check. So more than 10. Okay, 5 surely no. Okay, we want product. Okay, 5 times 5 is 25. 5 times 4, 20. 3, 15, 10, no. Then 4 times 5, 20. 16, 12, 8, no. Then after that, we have 5 times 3, 15. 4 times 3, 12. 3 times 3, 9. No. 10. 8. Sorry, this one's. Okay, is there any more that I might have missed out? Did I miss out any? No, right? Okay, so we are looking at having 8 favorable outcomes out of 25 possible outcomes. So 8 over 25 will be the answer. Okay, so this question over here brings us to wonder Okay, is there an easier way for us to determine the probability without having to draw such a possibility diagram? For questions like this, we are to consider the sum and the product. Okay, the answer is yes. There are other forms of possibility diagram that we could draw that will cater to this sum and product kind of situation. So for instance, if we look at work example 4, okay, because sometimes if you notice how I went on to find out the sum and the product, it can be a very tedious task, especially if there are very large numbers. You may in fact have to use your calculator instead of a mental sum to calculate. Or in fact, sometimes mental sum may not fully be reliable. Sometimes we may miscalculate, and then we miss out on some numbers for the probability. So in work example 4, we are looking at 2 fair dice. Okay, and we want to find the probability that the sum of the numbers shown is equal to 5. And even in the second part of the question. Okay, since the question specifically talk about finding the probability for the sum only, I'm not writing down the full question. Okay, you should have the textbook with you. So, since the question talks about sum, we can draw a different version of our possibility diagram. So what we will do is, we don't draw an axis, we draw a table, okay, with a plus sign at the corner to indicate that we are adding up numbers. Since you're looking at a normal die, we will have 6 columns and 6 rows. Okay, then we can do a quick addition. Okay, so this is another possibility diagram where we put in the sum of the numbers. Okay, put in the sum of the numbers into the table. So the probability of having the sum equal to 5 would be easily spotted from the diagram where we just hunt for the 5s. And there are 4 5s out of a total of 36 possible outcomes. So answer will be 1 over 9. Yes, Joseph? Where will we learn tree diagram? Maybe next lesson? Yeah, why are you in a rush? Huh? Oh, okay. Yeah, you will learn soon. Okay. Because our class goes in a different pacing as the other classes, right? We started differentiation, but the rest haven't. Okay, so part 2, probability that the sum is even. We spot out for the even numbers. So, even numbers. Be very careful when you draw such a possibility diagram. You don't actually take out the numbers at the columns, at the sides. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That will be half. Do not take for granted that when it comes to even and odd numbers, that it will always be half of all the possible outcomes over here. Because it really depends on what kind of numbers you're adding up. Okay, if you're not adding up same set of numbers, then surely it will not be half. Okay. Any questions? If no questions, I'd like you to do practice now for question 1 on your own. Okay, I will skip away from having to write on the whiteboard. I will show it on the visualizer in a bit. Practice now for textbook page 35. How do I switch this on? Oh, okay, it's on. the probability that the, okay, let's check our possibility diagram first. Okay, so someone tell me how should I fill up the possibility diagram for the sum? Joseph?
So in horizontal.
Anything up to horizontal?
Horizontal
Two,
is
6,
6, 7,
7,
3, 4, 7, 8, 4, 5, 9,
then
5, 6, 9, 10, 6, 7, 10, 11, 8, 11, 12.
okay, you got this? Now what about the product? Dylan? 1, 2, 5, 6, 10, 12, 10. Okay, so this will be the product. So what would the probability be for the sum if the sum bit should be even? Maybe what you get for answer? Half. Okay, so how do we get half? 12 over 24. Alright, we agree with that? Okay, part 2, what would your answer be, Joshua? You haven't do this? Then what were you doing? You took 5 minutes to do that. Okay. No, you just count out the table provided to you. Sum is divisible by 3. Sorry? 8 out of 24. Do we agree 8 out of 24? Okay. So I will not go into highlighting what is the even one, the divisible by 3 ones, yeah? 8 out of 24. Okay, is the answer. We would get 1/3 in the simplified form. Then after that, for perfect square, okay, what will your answer be, Carissa? Do you know what's a perfect square? Out of 24. Are we agreeable with that? 4 out of 24. Okay, so simplified will be 1/6. Very common, people tend not to simplify. Okay, and part 4 less than 2. Ling Hui. Sum less than 2. Sorry? 0, yes. Okay, there is no sum that is less than 2 in the table, so answer is 0. Then after that, C part I, product, okay, that is odd. Zhen Xue, what do you have? Sorry? 1/4. Okay, so how did you get 1/4? 1/24? 6. 6 out of 24 is equals to 1/4. So that's the probability for odd product. Okay, then after that, product larger than 12. What will your answer be? Katie? Sorry? 1/3. How do you get 1/3? 8/24. So there are 8 favorable outcomes. And then after that, for prime number, okay, what will your answer be, Ming? 5 out of 24. Right, so it cannot be further simplified. And finally, less than 37, Jinya? 1. Okay, because all the answers here are lesser than 37. So that answer will be 1. Any questions? Okay. Okay, the next one I want to go into is tree diagram, but I don't think I have the time to actually go into tree diagram. Is this the last lesson? No? Oh, too bad. Okay. Okay, then if that's the case, right, you can do question 2. Now, call it a day. There. I mean, I want to finish the 3 diagram part, then I can give homework, so I also cannot give homework. How come due next week? Because yesterday you're not here, so we all waiting for you. Yeah, so that you can submit on time. I'll upload the video later on for yesterday's lesson. Okay, can you please take some time to do this question? Draw out the possibility diagram. Joshua, your brain fried already. But just now you got 1 hour break.
Only 1 hour break.
You don't have AMATs, but yeah, you think you're tired or not tired? What's the next lesson?
I cannot read the question. The question very hard to read.
You would have known the question and you can read it if you had brought your textbook. So is it by fault?
No, I think from the textbook there, I can't understand the question.
You understand this question? All brain fried. Okay, I just read out. A circular car is divided into 3 equal sectors. It scores 1, 2, and 3. You need a ruler, is it? Card has a pointer pivoted at center. Pointer is spun twice. Okay, so one time, spun once. Okay, then after that spun another time. Spin another time. Each time the pointer is spun, it is equally likely to stop at any of the sectors. So that means that they are all equal probability. Okay, just like how a fair die actually works. So with help of the possibility diagram, find the probability that each score is a 1. Okay, so the score is done by, wait up. Did they say how the score is being calculated? Each score is a 1. Oh, okay. So we are looking at two different components. So if you want to draw a possibility diagram in this case, we are looking at first spin and second spin. So first spin we get the option of having 1, 2, or 3. Second spin we get the option of having 1, 2, or 3. Okay. So the score itself is per spin. So in one spin itself, okay, we want to be able to get at least a 1. Okay, right? Hang on, with the help. This part is pointer, but each score is a 1. Oh, so that means that in the probability of each score is a 1. That will actually mean that in each spin itself, we are getting a 1. Are you becoming a mom? I can bring beads for you and a shaver for you tomorrow. Okay. So we are looking at having 1, 1 as a favorable outcome. Okay, because our first spin is 1, second spin is also 1. So we get 1 out of total of 9. Okay. Then, oops, sorry, this is A part I. In part 2, the probability that at least one of the scores is a 3. That means it's either the first spin is a 3 or the second spin is a 3. Okay, because at least there's no 4 and 5, so we are looking at either 3, 3, 1, 3, 2, and 3, 3. Otherwise, 1, 3, 2, 3, and 3, 3. So that is a total of 5 out of 9 possibilities. Okay? Part B, I'll leave it to you to go and complete it at home. Okay, next Wednesday I'll just quickly finish this up, then we go into our tree diagram. Kind of, yeah. This part. Yeah, just do your exercise. Okay, this question just do your exercise too, no need to submit. Okay, I'll just go through it when you return.